Welcome back everyone. Today we are going to do the second lesson, which is a physics lesson, motion in a straight path. So in this lesson, it is a very easy lesson if you understand the terms correctly. So let's write down our first term, motion. What is motion? Motion is the definition of the motion. Definition of the term motion is change of position of an object of an body with respective to its surroundings is simply called as motion. So again, definition of the term motion is change of position of an object with respect to its surroundings is simply called as motion. So there is a motion type which is rectilinear motion, and it is also a term you have to be learned to understand this lesson perfectly. So let's write that too. The definition of the term rectilinear motion. Rectilinear motion. So this is a type of motion. Rectilinear motion is a type of motion. I will explain it. Rectilinear motion. So the definition of the term rectilinear motion is the motion which takes place in a straight path. So again, we have to learn the definition for the term motion, and definition is change of position of an object with respect to its surroundings is simply called as motion, and the definition of rectilinear motion is the motion which takes place in a straight path is called as rectilinear motion. So the definitions of these two terms are now being done, so we have to move on to the next part. If you want to write this, just pause the video and write it down. These are the correct definitions which we can study in this lesson. So you can study these definitions if you want, or you can write it in a notebook if you like. So okay, we are moving to the next term, which is a very important term, and they are quantities. They are quantities. The next subtopic is, and the next term or the subtopic is quantities. Under the subtopic quantities, there are two types of quantities. As the first one is scalar quantity. As I said before, there are two types of quantities. First one is scalar quantities, and the second one is vector quantities. So okay, I am going to explain both of these by the definitions of it. Wait. So okay, the definition of scalar quantities. So first of all I need to explain it. Scalar quantities are the quantities which only has a magnitude but not the direction. Again, scalar quantities are the quantities which have a direction but not, which have a magnitude but not the direction. Again, scalar quantities are the quantities which have a magnitude, which have a specific magnitude but not a particular direction. I will write it. As I said before, scalar quantities are the quantities which have a specific magnitude but not a particular direction, is simply called as scalar quantities but not a particular direction. So I am going to explain what vector quantities are. The vector quantities are the quantities which have both a particular direction and a specific magnitude. Again, vector quantities are the quantities which have both a direction and a specific magnitude. I will write it also. Vector quantities are the quantities which have both a direction and a specific magnitude is specific magnitude. And you will wonder what would be the examples for these quantities. If I tell 3 examples for scalar quantities, as you can see here, scalar quantities only has a specific magnitude. So examples would be like that. Distance is an example for it, and mass is an example for it. Likewise, we can get if the quantities only have a specific magnitude, it is definitely called as scalar quantities, and you can see 2 examples is down here. And if I take two examples for vector quantities has more variety of examples, but I will take only 2 examples for vector quantities. Vector quantities, as you can see here, vector quantities has a specific magnitude and also particular direction. So examples would be acceleration and weight. So okay, distance. What is distance? Distance is the total length, or distance is simply the total length between 2 places or more places, and displacement is the direct length of 2 places or more other places. If I give examples, mass is a scalar quantity, and acceleration and weight and except these 2 others are vector quantities. I will tell you how acceleration is created. Acceleration, if I write down the equation of acceleration, it is like this. Acceleration equal change of velocity. Change of velocity is represented by this measurement, which is meters per second, and time. change of velocity divided by time is acceleration. Time is in seconds. So likewise acceleration is a complete vector quantity. And weight I will get it on the top. If I write the equation of weight equal mass into gravitational acceleration. So mass is just a the measurement of measuring a dry mass. So if I take an example for mass, let's get 10 kg, 10 kilograms. So 10 kilogram multiplied by gravitational acceleration. Gravitational acceleration is 9.8 meters per square second, which is written like this, square second, but we get it as 10 meters per square second because 10 is easier to calculate. So when I multiply it by 10 meters per square second, the answer is 100. Weight is always measured by Newton, so weight is 100 Newton. As you can see here, there are two factors affecting the weight, so it is weight is a vector quantity.